Hi everyone. Today I will be presenting a review and a critique on this research paper titled Blockchain-Enabled IoT-BIM Platform for Supply Chain Management in Modular Construction. The presentation will cover four main sections. The first one is Introduction to Blockchain, just to get familiar with the terminology and what it's about. Research recap, going through the background methodology and the case study that we use for the evaluation of it, key findings and limitations, and recommendations for the future research. I mainly use the recommendations used by the author themselves because this research idea is kind of advanced and I don't have too many things to say about it other than the stuff that I already know. But I have some insights which I will share with you by the end of this presentation. Before we dive into the research, let's quickly define blockchain and understand why it is relevant in construction. So blockchain is a decentralized tamper-proof ledger. A ledger, imagined as a bank or a server that keeps records of transactions. So these transactions are recorded securely without needing a central authority, meaning that there are multiple servers or nodes that validate these records. In construction supply chain, this technology ensures trust and transparency among all the stakeholders, secure immutable data record, and automation of workflows, which we do it through via smart contracts to streamline the workflows. The technology can solve major challenges in construction supply chain management, particularly in the tracking, coordination, and data security part. So the blockchain attaches to the tracking, coordination, and data security part of it. Modular construction relies on multiple stakeholders to be coordinated. And the thing is, all of these stakeholders operate from different locations. So a major issue is fragmentation, um, leading to inefficiencies, delays, lack of transparency, and so on. So what has already been done in research is the implementation of IoT and BIM alone without the blockchain. And what they've done is that they added real-time material tracking with RFID, Bluetooth, GPS, stuff like that. They improved logistics with it and minimized manual record-keeping errors through using sensors. But despite these improvements, IoT-BIM platforms still face major limitations. And three major limitations that we are seeing this paper address it is the centralization risk. So it means that most of the projects rely on centralized databases, making them prone to cyber attacks that makes it a single point of failure. If that fails, if that server fails, everything's gone. So that's not good. The other part is data integrity issues. IoT devices generate huge amount of data, but first of all, they're susceptible to hacking. So you can't hack the database. If you can't hack the database, you can hack the data source, which are the sensors. So blockchain definitely fixes this as well. But the last and most important part is the lack of interoperability between different stakeholders. So many platforms struggle to integrate with existing BIM software and attach multiple admissions to stakeholders that can operate with each other. To overcome these issues, this study proposes a blockchain-based approach to secure, decentralized, and automated supply chain management to fix these three main limitations. The BIBP, short for Blockchain-Enabled IoT-BIM platform, I know it's kind of confusing, is designed using a three-layer architecture. So this method has three layers and integrates IoT, BIM, and blockchain. Each layer has a specific function. So at first we have infrastructure as service, or IaaS, that captures real-time data from the sensors and it pre-processes them via computing to send into the next layer. And the next layer is blockchain BIM as a service, or BaaS. This layer implements a dual channel blockchain. It means that it goes one direction upwards and one direction backwards, or downwards, let's say. So the downwards is that it connects with the sensors, and the upwards that it connects it to the stakeholders through the next layer. And the next layer is software as a service, or SaaS. I think many of you may have already heard this term because it's a kind of a I would say it's a entrepreneurship term because it's been going around for a while that entrepreneurs just make softwares and make so much money out of them. This is the concept. So they make a software to provide a service and it generates capital. Basically, what this does is that it's the part that it integrates different stakeholders. So provides a user interface for communication, process tracking, and data visualization. So let's recap very quickly. So at layer on the foundation, you have the infrastructure as service. There's sensors. These sensors get data sent to the middle layer, which is the BIM-enabled blockchain-enabled BIM. And it goes both ways, so it gets the data from infrastructure and sends the data to the software. So software as a service creates this platform which every stakeholder can talk with each other and communicate. So to validate the architecture or the system, the researchers conducted a case study that is owned by University of Hong Kong, and they're doing a modular student resident project. This project is two different buildings, each 17-story, and overall they have 1,224 prefabricated hostel rooms, which are stacked upon each other. And we have our main stakeholders. We have the owner, who's the university. We have the architect or the engineer, who is the contractor, and we have the manufacturer. So three main stakeholders we have here. And the study utilizes NFC and RFID tags to track the module components. For example, one of the things that this part does is that, for example, when a module is being transported in a truck, one of the key things that is important is how much the module is being vibrated. So the sensors inside those modules can sense the vibration to assess the quality of the logistics. So this is the key part where it just says logistics part. And the important part, which I find it to be most important, is the smart contracts, which automate quality checks and process approvals. So if there's anything wrong with the, let's say, the logistic part, and if it doesn't qualify the standards, the system doesn't approve it. So the work order gets stuck. When it gets stuck, someone has to address the issue. So that's the, I guess, the performance evaluation part where we address it this way. The benefits that was visible in this research are segmented into different parts. Well, the first thing that I noticed is that it fully developed a framework that can utilize these technologies and these advancements for supply chain management in modular construction, which is a huge step towards fully automating the process. You know, from factory to job site, it just doesn't get any much easier than this to automate everything. Limited input from real manual labor. It's amazing that they've done it. And there are some other parts that are interesting. The performance of it is good, even though it's still, it doesn't get too much into it on how this technology actually minimizes the speed that it takes to send the contract information. That specific part is a little bit tricky because the blockchain itself has been known for taking long to approve transactions on its network. And this is just this is just from before. Like anyone who has done any type of like investment in cryptocurrency through online websites, you're familiar with what I'm talking about. And I would say the two other parts are the successful case study, which they've done it in a real world situation, and the process that they've optimized the storage. So other than the speed of these transactions, the storage of the model is kind of something new. And they've used a model, a machine learning model called semantic differential transaction to minimize the space that the model takes in the server. This what it means is that they don't upload the entire model on the server. They only upload the changes within the model. This small change in the methodology uh, reduced reduced the size that the memory takes up significantly. If you go through the work itself, you see how much space they use. They save just with this. This study, even though I think it's very good, it has some concerns, mainly due to scalability, how the modules interact with the BIM platform. These parts that I'm discussing, it hasn't been significantly discussed other than the scalability issue, because the authors themselves discuss it that validation using a big project, an actual huge large project, is needed to fully implement it. This study only subliminally involves the framework validation in real world, just small. Other parts that are the main important things is governance issues on who accesses these laws and these regulations within the BIM blockchain network. That hasn't been discussed too much. And the most important part is the cost benefit analysis. Firstly, this technology is very expensive to implement, I know. I'm sure of it because it takes a long time to fully assign everything to the right user, the right permissions, and everything. And it's a very big architecture in general. And the other thing is that because this technology was used in a Hong Kong facilitated project, the technologies need to be assessed when we want to use them for a US based project, because the technologies that we use are different. We use Revit, we use BIM 360, we use Tekla, but as opposed to Chinese companies that use different BIM technologies. So the speed and the data, the storage that the model uses may differ significantly. So these parts need to be more focused in future. And lastly, I just want to do some recommendations. The authors themselves recommend the scalability enhancement of, using it for higher transaction volumes, doing it for multiple modules, multiple logistic situations, multiple attributes to assess. And the cost analysis is a must. So we have the technology, but we have to be understanding of how much it's going to cost us to use in our projects. And I would say that's the most important thing that we need to address for future research. And the main thing that remains, the other main thing that remains, is the governance of the blockchain model. Who has what access? Although very insignificantly, the work discusses how this model kind of works, which is based on an automated, if you have something that is not admitted by the regulations, the model stops issuing the admission to that infrastructure level contract. But when this discussed, you need to get more into it, see how it's defined, how you manage it. So this is my presentation for this research. If you have any question, feel free to ask. And if you have any more suggestions for recommendations, feel free to share with us. Thank you very much and have a nice day.